I am Michael Solomon, and I'm going to walk you through the running of the Assay1080 PIGF assay for preeclampsia. Helping me today is Arsh, who will prep the samples and load the samples into the cartridge.
So before we start the assay, let me give you an introduction to the Assay1080 system. This is the Assay1080 vertical flow cartridge. It has 5 wells, 3 positive and 2 negative. Samples will be loaded onto here. This is the substrate on which the test will be done. This is the Autovega instrument that we will run the assay on the cartridge. This instrument was built by Assay1080 engineers. The software to run the test was also developed by Assay1080 engineers as well.
Please note, the name of the company has been changed from Assay1080 to multiomeDx. In some parts of the video, you will see references to Assay1080, and in other places, you will see a reference to multiomeDx. They are one and the same company. Before we start running the assay, let's spend a moment reviewing the multiomeDx technology. This graphic shows the multiomeDx immunoassay concept in which antigen found in the sample binds to the multiomeDx probe. The probe has a fluorescent marker and a detection antibody. Once the sample is tagged with the probe, it can be read in the instrument where the fluorescence from the antigen-probe complex is read using immunofluorescence. The multiomeDx assays are highly sensitive, rapid, low cost, and are adaptable to bacteria, viruses, and other protein markers. The current Autovega instrument and software were designed and built by the team at multiomeDx. The Autovega instrument is designed to run the assay on the vertical flow cartridge and read the fluorescence from each of the sample wells. All steps of the assay, including incubation time, drain time, and buffer volumes, are programmable in the software. The current PIGF assay takes approximately 60 minutes to complete, however, can be further optimized to be run in about 30 minutes. The picture on the left shows the lab prototype that the team at multiomeDx has put together and is currently using for assay development. The demo that we will see will be run on the lab prototype. The rendering on the right side of the slide shows the Autovega product concept currently being developed by a contract manufacturing firm. The instrument will be compact and robust and is being designed to be CLIA waiver compliant. One of the unique aspects of the multiomeDx system is the filter-based wells in the vertical flow cartridge. After each step in the assay, the liquid in the well must be drained. The cartridge has a vacuum-based draining mechanism that the Autovega instrument uses to perform the draining. Liquid in the well of the VCF is drained through the membrane and captured in the cartridge holder. The graphic shows a cross-section of the cartridge and its operation. The VCF is designed to be disposable once the test is run, and all waste is contained within the disposable cartridge holder. Now that we are familiar with the multiomeDx technology, let's watch Arsh run the PIGF assay. Arsh will run 5 samples for this demonstration, 3 positives and 2 negatives. The VFC membranes have already been coated with PIGF capture antibodies. Arsh will add 100 microliters of positive serum sample to the first 3 wells. She will then add 100 microliters of negative serum to the last 2 wells. Finally, Arsh will add 200 microliters of sample buffer to all 5 wells. We are now ready to prepare the reagent tray. Probe, wash buffer, rinse buffer, and read buffer are inserted into their respective slots of the reagent tray. Once the buffers are in the tray, it is ready to be placed on the Autovega instrument. Arsh will now load the cartridge and reagent tray into the instrument. The lid is opened and the VFC is placed in the instrument and connected to the vacuum pump. The reagent tray is placed in the instrument adjacent to the cartridge, and the instrument lid is closed. Once the cartridge and reagent tray are in the instrument, the software can be set up. The test name is automatically generated by the instrument with a date and time stamp. The operator ID and kit ID can be input into the software, and the appropriate assay, in this case PIGF, can be chosen. Since this is a multi-well cartridge where only the wells in row 2 will be used, Arsh will select row 2 to process and read, since this is where the samples were placed. She will also set the appropriate incubation and draining times. The sample wells will be labeled with positives in wells 1 to 3 and negatives in well 4 and 5. Finally, the test is initiated and started. The test protocol that the Autovega instrument will run for the PIGF assay is shown here. All steps in orange are automated by the Autovega instrument. After incubating the sample for 30 minutes, the Autovega instrument performs a draining of the wells by turning on the vacuum. Next, the instrument adds wash buffer to each of the wells and then drains the buffer from the wells using the vacuum mechanism. The tip is then rinsed using the rinse buffer. The instrument then dispenses the probe to each of the wells and again rinses the tip. The VFC is incubated for 30 minutes and then drained, followed by a tip wash. The instrument then repeats the wash and drain step a second time. Finally, the instrument adds the read buffer to each well and the immunofluorescent signal is read from each sample. The software user interface for the Autovega instrument makes it easy to follow the progress of the assay as it runs. The test protocol that the Autovega will run for the PIGF assay is shown here. The step that is currently being run is coded in orange color. Once the step is complete, the color coding changes to green, indicating that step is complete. The well that is being assayed is also indicated in the display. Once the assay is complete, fluorescence measurements are taken on each of the wells. The results are displayed on the screen. The Autovega software displays the fluorescent readings from each of the sample wells. In this case, PIGF concentrations of 10,000 picograms in well 1 to 0 picograms in well 5. Results from the assay are also downloaded into a CSV file. In this case, sample 1 is shown in well A2 and sample 5 is shown in well E2. A standard curve can then be generated from the results. The limit of detection, or LOD, for the PIGF assay can also be determined. Once the assay is optimized, the standard curve and LOD can be finalized. As we have shown, the multiomeDx test for PIGF to detect preeclampsia is simple to run, can be optimized to be performed in 30 minutes, and uses low-cost reagents and instrument platform. The test will be able to be run in point-of-care settings once CLIA waiver is obtained. The multiomeDx technology can be applied to various bacterial, viral, and protein marker targets and can be multiplexed to provide even more information to the clinician. As we have shown, the multiomeDx platform is very versatile. We can map any lateral flow assay or ELISA-based assay to the multiomeDx assay format with minor effort. The result is a much faster and a much more accurate immunoassay. Samples can be blood, saliva, nasal, cervical, cheek swab, urine, or stool. A simple pre-processing step is required to get the sample ready for use on the multiomeDx platform.